like this is their first uh, course. We have people who have done it. So the purpose of mixing all of us is that we all support one another. We will try as much as possible to make sure that we go slowly. We start with the simplest concepts like this one, and then we start building up. So in terms of this course, you realize that the first talk um, did much of what I wanted to talk here. So I'll just be adding on what Tumbi talked about. Okay? So by the end of this training, we want to understand what is epidemiology, especially for the people who are doing this for their first time. We want to identify like how do we measure disease, how do we analyze disease, how do we generate hypotheses, how do we um, make causal concepts or causal inferences with the data we collect in the field. So basically, I will just be laying ground for all the other topics that will come after this. Okay? So to start with, because there are several people here who talked about they are doing epidemiology, they want to sharpen their skills so they understand what epidemiology is. So I just want two volunteers, one from this side and another one from this side, to just tell us what they think epidemiology is. Just one volunteer from this side to save on time. Now, when the facilitator knows your name, then you know you are at a risk. Boru, what do you think epidemiology is? Good. That's a very good classical definition of epidemiology. Someone else who wants to give us an applied definition of epidemiology, like what you think about it, not what is written in the books, but what you think about it. From this side, yes, my friend.
Yeah, maybe I can add that is a basic understanding of disease burden or distribution in a given place or region within a given time frame.
Excellent. That's good. So I think my work is very simple. So in terms of outline, what we really want to cover, we just want to understand what epidemiology is, how we use it, how it has evolved over time. Tumbi tried to like give us the evolution or the events which have taken place to build a case for modern epidemiology. So I will be adding a few other slides on what he talked about. We will discuss what are the approaches of measuring disease in our population. But all these things here will be covered in standalone lectures. So I'm just providing just an overview, okay? There are people who talked about they want to understand how to analyze data. We'll be laying a ground for that. And then for everything we do in epidemiology, we want to test an hypothesis. So we start from a point of we have an hypothesis which we want to test. So we will be understanding what an hypothesis is, how do we test it, and how do we make those inferences so that the data we collect then can inform policy after we analyze it and we draw those scientific conclusions. Okay? So there are like the classical definition of epidemiology, which Boru has talked about, which is the study of the distribution and determinants of health, um, and the application of that in controlling health-related So that's the classical definition of epidemiology. But for this course, we want to be able to look at epidemiology in terms of what do we do as epidemiologists? Like, what is the work of an epidemiologist? What can epidemiology do? Okay? And there's this guy um, with a name I can't pronounce in 1970 who talked about epidemiology as being concerned with causal factors or exposure. So that is one of the things as epidemiologists we focus on. Like, we identify a problem and we want to know what is the cause of this problem. Okay? And then there is a guy in 2006, that is very recently. I think Boru, you were born that time. It's very recently. So he talked about what we call modern epidemiology and what we aim to achieve with modern epidemiology. And he talked about it being as a process where we aim to improve health of populations. Remember that slide from Thumbi where he had a slide about what clinicians are concerned about, individual patients, and what epidemiologists are concerned about, the health of populations. Okay? And then he also talked about integrating data from different disciplines. So for you to like draw conclusions, you need data from different disciplines for you to be able to draw conclusions. Okay? And then after you draw your conclusion, then you are supposed to propose an intervention to solve that problem. And basically that's what epidemiologists are concerned about. Like, you identify a problem, you identify what causes the problem, and then you come up with an intervention to be able to sort that problem in the population. Okay? So basically, that's what epidemiology is all about. Okay? So just a continuation of that is we want to look at exposure and outcome. Okay? So for example, if you say you want, there's a problem somewhere. Let's say, for example, there are cases of diarrhea in a certain place. So you as an epidemiologist, your first goal is to identify what are the characteristics of the people who are getting this diarrhea. Okay? So that will give you like what could be the exposure. Okay? And then the outcome is the disease. So you want to look at, is there a connection between what I'm thinking to be the exposure and the disease or the outcome or the health related event. Okay? So that is basically what we will be focusing on. And then one of the things epidemiologists agree is you can have multiple causes to a certain outcome. Okay? So there can be different risk factors contributing to an outcome. Not like when we talk of, let's say, for example, malaria, we know you're bitten by a mosquito which is infected and then you get malaria. But for epidemiology, we look more on the exposures. Okay? And then we link that with data, like statistical analysis, to be able to draw those conclusions. Okay? So this is the classical definition I talked about, which all of us know about, and those who don't know can read there. But the most important thing is to look at the scope of epidemiology. When you look at this definition, it gives you like the scope of epidemiology, like it's a study, it's a science, okay? which is concerned with the distribution. So when we talk of distribution, we're talking about time. So distribution in terms of time. So when did the event take place? Okay. Distribution in terms of place. Where did the event happen? That gives us the geographical representation of the event we are talking about. Then we talk about determinants. So the determinants here are what are the causes of the problem we are discussing. Okay, what are the risk factors? And in this course, we are going to have so many like practical sessions for us to be able to analyze sample data, to be able to identify risk factors, to identify causes of different problems, and see whether that is associated with the outcome. Okay, and then we talk about events, health-related events, which can be either in the population, they can be in an hospital setting, they can be in a village, okay? All those, that's what we talk about the population. And then the most important thing is the application of the epidemiology. What do we do with the information we get to be able to inform policy or to inform action? Okay, because not anything we do is going to lead to a policy change. There are some things we do which you just need to inform policy. Okay, not policy but inform action. Like if there is an outbreak somewhere and you have known what is the cause of the outbreak, so you that will inform your action. Okay, so I just want to repeat this slide which Thumbi had about what is the focus of epidemiology. And if I heard that most of us here are clinicians, or there are also people who are in mathematics, there are people who are in health economics. But for epidemiologists, mostly we are more focused on the health of population, not an individual patient. Okay, and in doing that, we come up with questions. People who are doing research, people who are in like they are master students, PhD students. I know when you are writing your proposals, there is that part of what's the research question. Okay, so we are concerned with framing those questions and then collecting data to answer those questions. Okay, and then we draw conclusions, give recommendations, and mostly the other thing epidemiologists do, they do like impact evaluations. Epidemiology and M&D can fit very well because we have methods to do impact evaluations. So we evaluate programs to see whether whatever we are doing, is it causing change or not? Okay, so basically that's the work of an epidemiologist, and most of us here they fit in one way or the other in that frame. I want also to just give you this slide which you can read at your own time, but it's just basically trying to tell us what is the use of epidemiology. Okay, so we identify what are the causes of a problem, what are the risk factors. Okay, we also determine what's the disease burden in our population. We also try to understand what is the natural history of a disease. This is a slide which Thumbi had, so I'm just trying to build on what was presented this morning. And above all, we can use the data we have to be able to inform policy. So, for the people who have come when Tumbi had presented, he gave us like the progression of epidemiology, like where have we come from to be able to be where we are now. And there are those key people in the history who have contributed immensely to what we know today as modern epidemiology. And he talked of this guy called Hippocrates. Okay, so Hippocrates did a lot of work, which today forms the basis of what we call the modern epidemiology. Okay, so he is actually regarded as the father of medicine. And in his work, is this work indeed about airs, waters, and places, where he explored like how environment and climatic factors determine the disease patterns. Okay, so these are some of the people who started concepts which epidemiology has come to build on. And this was very early on there, like 400 years before. For those who are Christians, we can say before Christ. For those who do not know Christ, then we can say BCE. Okay? So you can see these things started long time ago. Okay? And this guy laid the foundation for epidemiology, looking at how the environment actually contributes to exposures which can lead to an health related event, okay, or a disease. And then that moved to another key guy called John Snow. I know most of the people who have done an epidemiologic course, they know John Snow because he's always given as the person who like is the father of modern epidemiology, because in those early days he contributed to shaping the modern practices in disease prevention and public health. From his work on identifying cholera cases in London and trying to look at how that was related to distribution of those cases, how contaminated water was leading to cholera. And that was 30 years before people came to identify the cause of cholera. Okay, so that shows as an epidemiologist, you can even control a disease without knowing, or a health event without knowing what is the cause. Okay, so this is the guy here who is regarded as the father of modern epidemiology, and he did some very nice work with that pump in London, Broad Street, where he was able to demonstrate that by removing that pump, then he was able to control the spread of cholera. Okay, and this I think Thumbi showed a better map of this, showing the how these cases were in the same place, just near the pump, where the pump was. Okay, and then we have what is known as the coach postulates. There are people who also have learned this in school previously, and there's this guy who like conducted some investigations. Okay, also on cholera, did some line listing, did some maps on trying to link like how is how do we say that and disease is caused by X and not Y. Okay, so there is some good work which was done by Koch, and there's this process of how you determine what is causing a disease. Okay, and he established a criteria for like trying to say this is the cause of disease or it's not the cause of disease. And the first one was the presence of the microorganism which is causing the disease. Okay, so he said for a disease to occur, then the microorganism must be found in all the organisms which are suffering from that disease. Okay, and then he talked about the microorganism must be isolated. Okay, and the disease must be able to be like reproduced in an animal. That's why you are seeing those rats there. And then once you grow that microorganism, you should be able to re-isolate it again. So that also formed the basis of what today we call microbiology. Okay, and then when Tumbi was talking, he talked about limited historians or people in the history who talked about who contributed to epidemiology who are women. So I quickly tried to get just one to, to, to be able to fill that gap. So there is this lady who is called Florence Nightingale, who was a nurse, and she did some very good work about trying to look at the work of nursing and how it contributed to public health action, including medical statistics and those kind of things. So this is the lady here who was who is said to be the pioneer of medical statistics health analysis. Okay, so he drew maps to be able to show. He drew charts. So there are these charts which were looking like what today we would call like those maps. He drew them like what we call pie charts today. So he had a fashion of pie charts in those early days. So she has contributed a lot on the statistical methods we use for um, trying to come up with inferences for health related events. And then finally, just to make sure that we are linking what we call like to make sure that we are also looking at data is this guy called William Farr. Okay, and William Farr also did a lot of work on medical health statistics. Okay, he was that person who came up with the analysis of mortality trends. He came up with the analysis of like health records in London, and he was what we call nowadays like vital statistics. This is the guy who started that long time ago. And then there's also this guy called Kevin. So Kevin has done a lot of work which is has built on what today we call One Health. So what is One Health first? There's a lot of talk about one medicine, a lot of talk about One Health. What do you understand by One Health? Yes, my friend.
Yes, just to give a trial, One Health approach encompasses the multidisciplinary approach of different departments, like the veterinary, well, animal health team, public health, the environmental reasons, with the aim of ensuring that during disease outbreak investigation, all
That's a nutshell what One Health is. It's a multidisciplinary approach, a collaboration where you have all hands on deck. Like if it's people in human health, people in veterinary medicine, people in ecosystems, you all like work together to solve a particular problem. And this guy started that. He started with the emphasis on zoonotic diseases, like those diseases which are transmitted from animals to humans and how we can control them. He even wrote a book about one medicine, which you can also look at it for at your own time and read it. So he was like the first person who came up with that kind of approach where there is a lot of collaboration in us solving health related events. He helped in trying to have that holistic thinking when you talk about disease causation. Okay. So that's so much about history of epidemiology and how it has come and the people who have contributed to it. We want to move next to look at how is disease transmitted. Okay, and in terms of disease transmission, we are concerned about the host, we are concerned about the environment, we are concerned about the agent or the vector. And in doing all this, our work as epidemiologists is to make sure that we can identify what are the like risk factors or the causes from each of these uh, places, whether it's in the environment, whether it's in the agent, whether it is in the host. So that's what we do as epidemiologists. So if you look at the host, you want to look at what influences the risk of exposure to the host. Okay, we are looking at things like susceptibility to infection. We are looking at what are the factors which can contribute to that susceptibility. What it can be like demographic factors like age. There are those events which are more commonly in a certain age of people. There are so others which are due to a lifestyle of some people. Okay, there are others which are due to a genetic makeup of people. So when you look at all that, then you as an epidemiologist, you want to identify what are the risk factors in those groups and how do we minimize them and or how do we prevent them. Okay, and then when you look at the environment, then now here you're looking at what opportunity is there for exposure to some physical, biological, or socioeconomic factors. Okay, it can be physical, it can be some climatic changes. Biological can be agent population density, vectors, things like this. Socioeconomic can be human population distribution. It can be uh, where you are living in terms of your status. All those kind of things is what we are concerned about. And then when we look at the agent, here we are looking at the factors which drive things to cause disease. Okay, is this biologic like microorganisms? It can be physical, it can be nutrition, all those things. Epidemiology is concerned about all those things which can influence disease to happen. Okay, so when we talk about trying to be able to analyze data to come up with a cause for the problem, we are concerned about, if it is descriptive, we are concerned about three things which we can all focus on, and that is time, place, and person. Like when did the event occur, where did it occur, and who is affected. If we can answer all those three questions as an epidemiologist, then you are okay. Okay? And then once you understand that, we analyze the data to look at the association between the event and the risk factors. Okay? And then finally, we make a recommendation for control or for prevention. Okay? So there's this thing we are calling an hypothesis. Okay? So for the people who have done epidemiology, what do you think an hypothesis is? In layman's terms, don't define the way the book is, the way it is defined in the books. Like, what do you understand by the term hypothesis? Hmm. I can see you are smiling, so that means you have the answer. Anyone? Yes, yes, Cosmos. Hmm. Okay. Yeah. So in simple terms, it's just an educated guess. Like you start with guessing. I think this could be the cause of what I'm observing. Okay? And then you move from that guess to try and come up with solution to test that. And that can be a data collection to be able to prove and test whether the guess you have is right or wrong. Okay? I will not go into depth of trying to talk about testing of hypotheses because we will do that in our subsequent lectures when we are analyzing data. We will come up with, we will talk about if it's null hypothesis with the alternative hypothesis, how do we test it, how do we construct a 2 by 2 table to be able to answer those questions. So all that will be covered in the subsequent lectures. But for this one is just for me to tell you that as epidemiologists, our work is mainly to be able to come up with hypotheses which we can test, and then once we test, then we are able to come up with conclusions. Okay, so we say it's an educated guess or it's an explanation based on observations. So you have made an observation, and based on that observation you have like an explanation to what is happening based on that explanation, but you are not able to say exactly whether that is the cause. So what you do is you go ahead and collect data, analyze the data, test that guess you have, and if it is true, then you say you are right, and we'll tell you the mechanisms through which you can be able to say whether your hypothesis is right or wrong. Okay, so some of the sources of hypothesis could be observations like patterns of disease, things like that. It could be from existing data, like people who work in hospitals. You may be having some cases happening there. When you look at those cases, then you can start drawing some conclusions to say maybe in a certain place something is happening because we are seeing cluster of these cases from a certain place. Okay, it could be from anecdotal evidence. So those kind of things, like when you go to the village, you'll be taught so many stories. So those are things we call anecdotal evidence. So you can also get an hypothesis from there, and you try to test it. Okay, and if you look at the work which John Snow did, he was able to hypothesize that cholera was waterborne from observing the cluster of cases near the water source. You remember that pump? So that's an example of a very simple hypothesis. Like cholera was waterborne. It was associated with that water source. Okay, and then in terms of the process we go through to generate hypothesis, we make the observation, then we look at the data, try to define what exposure is, what outcome is, and then we test that, and we'll be able to show you how to test hypothesis from a practical point of view with some sample data. Okay, I'm almost finishing this. So in terms of epidemiology, we always want to try and come up with a causal inference, like to be able to say this is the cause of the problem we are seeing. Okay, we want always to determine that there is a relationship between the exposure and the outcome. Okay, and there are several methods for us to be able to do that. There are studies we can do, and one of the gold standards of being able to say what is the whether the exposure and the outcome are related is when we do these randomized controlled trials. Okay, and we'll be able to learn about all these study designs and how they are implemented, how the data from these study designs is like analyzed. Okay, and then in terms of trying to look at whether exposure and outcome are related, they are what we call confounding factors. Okay, so those are factors in between the exposure and the outcome which are not related. So, and in most cases, without proper design of studies, sometimes we make the wrong conclusions. Because of these confounders, if we don't control them well, we make the wrong conclusions. Okay, and we'll be able to show examples of those when we talk about validity of studies. Okay, so there's a criteria which is used to determine causality, and that will be covered tomorrow when we cover in depth causal concepts. Okay, so I have 5 minutes to complete this, but I want to just give you like a summary of what we will be doing in this course. Okay, so epidemiology is just concerned about us identify causal association between exposure and outcome, and that is what is in that center of that diagram. My apologies, cannot see it well, but we will share the slides so we'll be able to look at it. So the work of epidemiology is to identify associations between the exposure and outcome, and in between there you have the confounding factors which you need to control. Okay, and we'll talk about all that. Okay, but all the time we start with the population, because the work of epidemiologists is within the population. So you come up with what is your target population, then you come up with a nice study design to address that kind of problem, which makes sure that the target population you like identify is free from selection bias, and that's why we talk about things like sampling, which we are going to learn about in the course of the week. Okay, then when you have done this study design, you have selected your population, you are trying to look at whether exposure is related to the outcome in terms of data collection. Once you have this data, then we analyze the data, and there are different data types. which we are going to talk about. It can be either continuous, it can be dichotomous, it can be clustered data, all those data types, we are going to talk about them. So once we analyze that, then we want to make an inference, okay? We want to analyze the data and determine whether there are any cause or effect of the exposure and the outcome. And then we come up with finally what we are calling a causal inference. Like you are able to say that the problem I have is associated with this exposure or this outcome. So basically what we are going to be doing in this week is to be able to come up with a study. Like if you are an epidemiologist or you are working on something, you'll be able to identify a problem in which population, come up with a nice study design, collect the data, analyze the data, and make some inferences from that data. So in nutshell, that's what we'll be doing from today up to Friday. So that is basically what we will be doing. So we have 3 minutes to ask any question before we go for tea break. Anyone with a burning question? So this was just like the introductory part, just laying the ground on what we'll be talking uh, now in more details. So anyone with a question? Okay. So if there is no question, then I think we can take a break and come back at 11, exactly at 11. If you realize we are within the program, so we don't want to deviate, because if we deviate, that means we will leave here late. So we can go for tea. Make sure that you network, because we don't have time slot for networking. So that by end of Friday, we tick that box of networking. Okay? So tea is served somewhere there. So enjoy your tea.